we start with our next problem solving session. And before going for the problem solving session, if you have not subscribed, comment and like my channel, please do it. The links for my previous video already mentioned in my description box. Please subscribe it because it is easy for you to go through my all videos and it is easily available to you once you subscribe my channel. So we start with our problem solving sessions. Please be with me and try to understand the very basic concepts of network, how we apply those concepts in finding out the solutions. Okay, this is our first problem. Okay, this is our first problem. Again, in this problem you have to find the equivalent resistance at terminal A and B. You have to find the equivalent resistance at terminal A and B. So now see how we will find that equivalent resistance. So before solving this problem, just see, this is a branch which is connected between these two nodes. So what I will do, I will call these nodes as, say these node as, it is, say it is 1, it is 2, it is 3 and it is 4. Just for understanding purposes, I have just mentioned the nodes as 1, 2, 3 and 4. Now what we will do, if you see between these 3 and 4 node, between these two nodes, that is 3 and 4, you will find there is no resistance. So you can say these are the node of same potential. Yes, you can say these are the node of same potential. So can you say that we will redraw this network as so can you draw this network in this manner? See, again your 10 ohm resistance, this is your 3 ohm resistance. What I did here, since it is a same, this is a node where there does not exist any resistance, you can say these two nodes are of same potential. So this 6 ohm resistance, we can just superimpose this node into this node or this node into this node. So I will say this 3 and 6 is in parallel and 12 and 4 is in parallel. This is your 1 ohm resistance, this is your 5 ohm resistance. Okay, so if you see these two resistance are in parallel, these two resistance are in parallel. So can you able to find the parallel combination of these two resistance? Yes, if you see, if 3 and 6 is in parallel combination, so you know how it is solved. It is 3 into 6 upon 3 plus 6, very simple. So that comes to be 18 upon 9, that comes to be 2. So I can here directly draw the network as, this is our next step, this is our second. So this comes to be 10 ohm, this comes to be 2 ohm, this is your 1 ohm resistance, this is your one more resistance, and here is the resistance. This comes to be how much? It is how much? 5 plus 1, that comes to be 6 ohm. If you find the parallel combination of 12 into 4 upon 12 plus of 4, that comes to be 12 into 4 upon 16, 4, 4, 4, 3. Okay, so that comes to be 3 ohm. So this is your 3 ohm. Now you see this 3 ohm, if you see this branch, this 3 ohm and 6 ohm is in what? Is in parallel. So you can find the parallel combination of these 3 and 6. How much it is? The parallel combination of 3 and 6 comes to be how much? It comes to be 2 ohm. Just now we have solved it. So I will directly write as step third, So this comes to be, it is 10 ohm. This is your resistance. Okay, this is 1 ohm, and this comes to be, this is 1 ohm, this is 2 ohm, this is 2 ohm, and this is 10 ohm. Okay, so now we have solved this, and that comes to be 2 ohm. Now your fourth step is what? This 2 plus 1 comes to be 3, and 3 is parallel to this 3 parallel to this 10 ohm. So once again I will draw this. So that comes to be in this fashion. This is your 10 ohm, this is 2 ohm, and this resistance comes to be again what? This 3 ohm. These terminals again as A, B. So finally, can you say the value of R equivalent at terminal AB is what? These 2 and 3 are in parallel. I will write in this fashion. This represent 2 and 3 are in parallel, and it is in series with 10 ohm resistance. So this is your value of R equivalent. So if you find the value of R equivalent, so 2 into 3, 2 parallel 3 is how much? 2 plus 3, that comes to be 3 to 6 by 5, that comes to be 1.2. So you can write here as 1.2 plus of 10, that comes to be 11.2 ohm. This is the value of R equivalent. Very important. With this we have solved our problem. The value of R equivalent comes to be 11.2 ohm. Okay, just by repeating one can easily understand how we have solved this question. Okay friends, this is our next problem. In this problem you have to find the G equivalent. Now the question comes to be, what is G? What is G? G is known as conductance. G is known as conductance. Okay, as you know, R is known as resistance. G is known as conductance, and what is the relation? G is 1 by R. Very important thing. Most of you know about this. G is 1 by R, or you can say, if you find the unit of G, that comes to be what? It is in this form. The unit of R is ohm. The unit of G as, we call it as mho, or it is represented in form of Siemens. Okay, we call it as S also. So you have to find the G equivalent at these two terminal AB. Now we have seen the equivalent combination of resistance in case of series as well as in case of parallel. Now the question comes, how we'll find in case of conductance. So just keep in mind, I am not going to solve the entire theoretical portion here. You have to just try to understand that whatever the concept we have applied in case of resistance in terms of either series combination or a parallel combination, it is just get reversed in case of conductance, that is G. Okay, so whatever you find in case of resistance, like if I talk about series, so if resistance, if you have to find the equivalent resistance, what you will do, say there are two resistance R1 and R2, so you simply add R1 plus R2. But in case of, this is in case of R equivalent, in case of if you have to find G equivalent, so what you have to do, it is basically 1 upon G equivalent upon 1 upon G1 plus 1 upon G2. This is for the case of series combination. Similarly, when you talk about parallel combination, so in that condition, if there are two resistance, so you can find 1 upon R1 plus 1 upon R2. But when you find G equivalent in case of parallel, so that's simply G1 plus of G2. So I have just taken an example of two resistance R1 and R2. Similarly, it is G1 and G2, but you can add n number of resistor. Okay, and accordingly the combination changes. Okay, So this is about series combination. When resistance are there, so it is simply added. But when you talk about G equivalent, so this is the way in which you have to find the G equivalent. Okay. Similarly, when parallel combination is there, so we'll find resistance in this manner. However, G equivalent will find by adding directly G1 and G2. Okay. So this you have to keep in your mind. So with the help of these two, this 1 and this 2, we will solve this question. So as I mentioned earlier, so with the help of that concept 1 and 2, we will solve this. So now you see first, see these two elements are in parallel. Okay, these two are in parallel and these two is in series. So what we will do, either we will solve this also and we will solve this also. So if I talk about 8 and 4, if I talk about this 8 Siemens and this 4 Siemens, okay, so these are the two conductance which are connected in parallel. So how you solve this? See, I am going to solve this. Okay, so since these are connected in parallel, so as I said earlier, simply you have to add. So for these 8 Siemens and 4 Siemens, since connected in parallel, so it's equivalent. How you will find its equivalent? Equivalent G. So that comes to be, simply you have to add it. So that comes to be how much? It is 12 Siemens. Okay, that comes to be 12 Siemens. Why? Because it is connected in parallel. Simply we have added. Now come to here. When we are talking about this 6 Siemens and this 12 Siemens. Okay, now we are talking about this 6 Siemens and 12 Siemens. And now if you see this 6S and 12S, you have to find equivalent of G. It was in parallel and now they are in series. Okay, so when it is in series, so simply 6 into 12 upon 6 plus 12. So that comes to be 6 into 12 upon 18 and that comes to be how much? It is 4S. So the when you solved it, I will redraw this network. So that comes to be how much? See, this become, okay, it is solved. So this is your, this is solved as 12S, this is 2S. Okay, and what about this? What about this? This is in parallel with this. Okay, and the value of this comes to be how much? It is 4S. Okay, that comes to be 4S. This is A, this is B. These two are in again parallel with this 2 Siemens. Okay, now we see further. Now you see this 2S and 4S. This 2S and 4S is in parallel, so simply it is get added. So our second, that comes to be, this is A, this is B. This is our second step. So this is your 12S. So as I said, this simply get added. So this become how much? This 6S. So you have to find G equivalent at these two terminals. So what is G equivalent? Since this is in series, so as I said, you have to find in this manner. This comes to be this much. That comes to be 12 into 6 upon this 18, 3, and that comes to be 4S. So the value of G equivalent comes to be 4S. Okay, so the value of G equivalent at terminal AB comes to be 4 Siemens. Okay, or you can find the value of R equivalent also. So that R equivalent comes to be 1 by G equivalent, so that comes to be 1 by 4, that comes to be 0.25 ohm. This you can also find here. Okay, now we proceed with next problem. Now this is our next problem in which you have to find R equivalent at terminal AB. Please try to understand the problem. This is some kind of structure in which these are the resistance which are connected, and basically you have to find the equivalent resistance at terminal AB. So this is your 5, 20, 3, 6, 8 and 10 ohm, which is very clearly seen here. Okay, so we will find the equivalent at AB. So just try to understand, these are the two nodes and these nodes are of common potential. Why? Because it is simply connected by a branch. It is simply connected by a branch. So I redraw this network as, please see, I am going to redraw this network as, should I draw in this manner? Now see, should I draw this network in this manner? Yes. See, these two nodes, okay, I have directly connected these two nodes in this fashion. Yes, and I just stretch these two nodes again as A and B, where the resistance is, this is 10 ohm, this is 8 ohm, this is 6, this is 5, this is 20, this is 3 ohm. Okay, once again I redraw this network as, now should I draw this network as this? Yes. See, again it can be connected because it is a node of common potential which is simply connected by a branch. So I should superimpose this node over this node. So this is your next figure. Basically you can say this 5 ohm and 20 ohm resistance are in parallel, or you can say this 6 and 3 ohm resistance are in parallel. So one can easily find the parallel combination of this resistance and will solve this problem. So like that you have to find. Okay, this is these two resistance which is showing in green color is basically the equivalent of these two resistance which are connected in parallel. Okay, which I am going to redraw here. Now see, I have redrawn this network here. This is 10 ohm. The parallel combination of 5 and 20 is how much? It is 4 ohm. Again, parallel combination of 6 and 3 is how much? It is 2 ohm, and this is 8 ohm. So what is our equivalent? Yes, you can directly say it is 10 plus 4 plus 2 plus 8. So that comes to be 24 ohm. So this is the value of R equivalent, that is 24 ohm. Just by repeating, try to get this problem. Okay. Okay friends, this is our next problem. Now you see, in this problem, this is a kind of problem in which you have to find again the R equivalent at this terminal. Now why I have taken this problem? you'll see it's a very big problem. This is a very simple concept which is applicable here, and that's why I have taken this problem. Sometimes this is used to come in GATE in different form, but if you start solving this with your traditional method, it will take a lot of time. So you just waste your time in your competitive examination. So how one can able to solve such type of problem, this we will try to understand. See, whenever you find this type of structure, I have just taken one structure here. Basically, if you see, it is a kind of structure. Yes, this is a kind of structure. Can you say like that? Yes, you can say. And here is some resistance connected. So if you see, this is a kind of Wheatstone bridge. This is a kind of concept of Wheatstone bridge that we will see. But just keep in mind, when these resistance are same, say this is R ohm, this is R ohm, this is R ohm, independent of this resistance, independent of I can say value of this resistance, okay. So independent of value of this resistance, if you find these resistance found to be R ohm, then the equivalent resistance at these two terminal AB is always R ohm. Just keep in your mind, very important thing, the equivalent resistance at these two terminal is what? It is R ohm. So very important concept and applicable in so many areas. We will see how R ohm we will find, that is a different thing. You can easily find using star to delta or delta to star transformation, one can easily able to understand. But for the time being, please keep in your mind, whenever you find such type of structure having all resistance are equal, very important condition, these all resistance must be equal, very important thing. And whatever the value of the resistance here, it doesn't mean anything, okay. So if all these resistance found to be R, and you have to find the equivalent at terminal AB, so the value of equivalent terminal is what? That is R ohm, very simple. So if now you see this, it is similarly like the same what we have discussed earlier. So if I redraw this network as first, so can you draw this network like, should I directly write here? Should I directly draw this network here as? Yes, this is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ohm. So we just solve this one, okay, and we write it as 1 ohm. Similarly, we solve this and we write it as 1 ohm, okay. So if once again we'll redraw this network, we'll see this is our second, that finally comes to be what? If you solve this, this is 1 ohm, this is 1 ohm, this is AB. So what is our equivalent? It's 1 plus 1, that comes to be 2 ohm. This is the value of your R equivalent. Very simple. Just by solving this, because all resistance are same, you can directly write it as 1 ohm. And 1 ohm is in series, the value of R equivalent comes to be 2 ohm. Okay.